This video is on function of the function rule and how it applies to exponential functions. So if we have an exponential function y equals e to the power of f of x, where the exponent is another function, then to differentiate this, we're going to find the derivative of that exponent, which will become f dash x, and multiply that by the original function, e to the power of f of x. So in the first example here, the power is x on 2 and the derivative of x on 2 is half. So if y equals, the correct way, I noticed in some of your books the setting out for this, we're going to go d dx of e to the x on 2. We can't just say that equals the derivative. Okay, so d dx of e to the x on 2 saying the derivative of e to the x on 2, that's going to be half, which is the derivative of the power, and then times by the original function. So the answer is half e to the power of x on 2. In number 2, we are going to find the derivative of e to the power of x cubed minus 2x. So the power is x cubed minus 2x. We're going to find the derivative of that and multiply it by the original function. So the derivative of the power is 3x squared minus 2, and we're multiplying all of that by the original function, e to the power of x cubed minus 2x. Okay, in number 3 here, we have a function raised to a power. So just like we did in differentiating polynomial functions raised to a power, we bring the power down the front, we keep the stuff in the brackets exactly the same, and subtract 1 from the power, so 2 minus 1 is 1. And then we multiply by the derivative of what's inside the bracket. So the derivative of e to the x is e to the x, and the derivative of minus e to the negative x, or the derivative of that power there is negative 1, times that out the front here becomes positive 1, and then you've got keeping the exponential function the same. So that then becomes our derivative. Okay. I didn't put the correct notation in front of that one though. Number 4. Let's differentiate x squared minus e to the 2x all to the power of 4. So we are going to bring the power down the front, keep the brackets exactly the same, and subtract 1 from the power, then multiply by the derivative of what's inside the brackets. So the derivative of x squared is 2x. The derivative of e to the 2x is going to be minus 2e to the 2x. So remember, that's differentiating the power, multiplying that by the original function. So let's close off those brackets. Now what else do we see here? I guess if we did want to find stationary points, we would have to make the first derivative equal to 0 and solve for x. So you can see there's a 2 there, common factor. We can take that out the front, multiply it by the 4, and you get just a nicer form there. Then we're left over with e to the power of 2x. Okay, find the second derivative. So just like you're differentiating before. So we're going to find, let's do some different notation. Let y equal e to the negative 5x. That means y dash is going to equal negative 5 e to the negative 5x. And then y double dash means we have to multiply this by negative 5. Because negative 5 is the derivative of that power. Okay, in B we have two functions in x cubed times e to the x, the product of two functions, which means we used to use the product rule to differentiate. So let's let u equal x cubed. Oops, I don't know if that's, you can see that u dash equals 3x squared. V equals e to the x, and v dash is also e to the x. So product rule is insides plus outsides. So if we let y equal x cubed e to the x, then y dash equals 3x squared e to the x, so the insides plus the outsides, which is x cubed e to the x. Alright, so that's the first derivative. To find the second derivative, we've got to differentiate this. So differentiate this and then differentiate this. To differentiate this first term, we have to use the product rule again. Awesome. So let's maybe use green for this one. It's differentiating this first term. Looks like we're going to have to use the product rule again to differentiate that second term. So differentiating the first term there, we let u equal 3x squared. So u dash is 6x. V is going to equal e to the x. So v dash is also e to the x. And so let's work out, I might start over this side, y double dash. So it's going to be insides 6x e to the x plus, is it not a nice x, outsides 3x squared e to the x, and now we have to differentiate the other term. So differentiating this one here, we'll let u equal x cubed. So u dash is 3x squared. V is e to the x, and likewise v dash is e to the x. So now there is a plus here in the middle, so we're going to put a plus there in the middle. And it's going to be insides, which is 3x squared e to the x plus outsides x cubed e to the x. And do we have any like terms here? Let's see, we've got x e to the x. Ooh, nope. We've got x squared e to the x. Ooh, yeah, it looks like that one there and that one there are like terms. So we've got 6x e to the x plus 3 plus 3 is 6. X squared e to the x plus x cubed e to the x. Alright, there's our second derivative. That was fun. Last example. Find the stationary point on y equals x e to the x and determine its nature. So remember, stationary points occur when the first derivative equals 0. So let's find the first derivative. If y equals x e to the x, we got a function multiplied by another function, which means we need to use the product rule again. So u equals x, u dash equals 1, v equals e to the x, so v dash is also e to the x. So y dash, we'll do that over here, is insides e to the x plus outsides. Okay, stationary points occur when y dash equals 0. Let's make that equal to 0 and solve for x. So we have a common factor there of e to the x. Let's factorize that out to help us solve this equation. Now we have the product of two things, either e to the x equals 0 or 1 plus x equals 0, because their product equals 0. So that means we can say either e to the x equals 0 or 1 plus x equals 0. Now remember, e to the x is an exponential function that looks like that. It never equals 0, so there is no solution for this equation. And over here we just have a linear equation. You can see x is going to equal -1. So we have one stationary point at x equals -1. Because it's asking for the stationary point and its nature, we need to find the y-coordinate of the stationary point, which we can find by subbing into the original equation. So we're going to let x equal -1. So let's do that and see what we get. We get y equals -1 e to the power of -1. And that can be simplified to -1 on e to the 1, which is just -1 on e using our negative index laws there. So our point is going to be -1 on e. Now we need to determine its nature. So we can either use the first or the second derivative test. For the first derivative test, we could draw a table. Well, let's do that. I think we'll draw a purple table. And we're going to have our x value of -1. We're going to, in the first derivative test, we're going to work out the first derivative or the gradient before and after the turning point. Now you know that at x equals -1 the first derivative is 0 because we just did the reverse of that over here. We made the first derivative equal to 0 and solved for x, which was -1. So let's choose a value before -1 and after -1, and let's sub that into the y dash, which is the gradient function, to work out the gradient before and after the turning point. So y dash, that is over here or over here. And if we make x equal -2, then you can see here this becomes e to the x outside of 1 plus -2, or 1 minus 2. 1 minus 2 is -1, so that's going to be negative e to the x. Oh, and x is -2, so that's going to be -2, which is -1 on e squared. Now, e is a positive number, but when you've got -1 divided by e squared, that means that's going to be a negative value. So a negative gradient means we're sloping like this. Now let's sub in x equals 0 into the first derivative. When x equals 0 here, you get 0 times e to the 0, which is just 0. And you're going to have e to the power of 0, which is +1. Remember, anything to the power of 0 is 1. +1, which means we've got a positive gradient there, and you can see that this is then going to be a minimum turning point or minimum stationary point. So our stationary point is a minimum, and that is at -1 on E.